morning, students. I am Dr. R. Srinivasan from Freshman Engineering, IARE. So today we will see ion selective electrodes and introduction to primary and secondary batteries. In the last session, we have seen different types of electrodes. In that, we have seen ion selective electrodes. So we continue with some more information on ion selective electrodes. And then further we will see primary and secondary batteries introduction. Now, what is ion selective electrode? The electrodes which have the ability to develop potential of a certain specific ions without causing interference from other ions in the mixture are called ion selective electrodes. So yesterday we have seen example glass electrode. Glass electrode is an example of ion selective electrode which is used in the measurement of pH. Measurement of pH. Okay. So what is the principle behind this ion selective electrode? The principle of concentration cell is used in the construction of ion selective electrodes. Principle of concentration cell we have seen in the last session. Okay, this also we have seen in the last session. There are glass electrodes, one example for sensing the H plus ion concentration and further pH of the solution. And solid state membrane, for example, this is glass membrane. Here it's solid state membrane for fluoride ion sensing. Ion selective electrode for fluoride sensing. Lanthanum trifluoride mounted on europium difluoride is used. For chloride ions, pellet of Ag2S and AgCl is used. Okay. So this is what we have started yesterday. Next, working principle of ion selective electrode. In short, ion selective electrode, we say ISE, ion selective electrode. What is the working principle of ion selective electrode? We have already seen is based on the construction of concentration cells. So what is concentration cell also? We have seen that the concentration of solution only is different. Electrodes are same. Both the electrodes are same. Only the concentration of the salt solution in which it is dipped, their concentration varies. That's what it's called, concentration cell. And we have also seen that the lower the concentration, that electrode acts as an anode, and higher the concentration, it acts as a cathode. Okay, so in this cell is constructed like this. You have a reference electrode, you have a test solution with concentration C1, internal standard with concentration C2, and internal reference electrode, okay, ISE, internal IARE, internal reference electrode. Okay, so whenever a thin glass membrane is in contact with two solutions of different H plus concentration, which is a type of concentration cell, the potential developed depends upon the H plus ion concentration of the test solution, okay, whichever you want to test. The potential of glass electrode, which is a ion selective electrode here, is given by Nernst equation. Eg is equal to Eg naught plus 0.0591 by N logarithmic concentration H plus, where E naught G is the standard electrode potential of glass electrode at 25 degree centigrade, which is plus 0.56 volts. Okay. So glass electrode, how it will look? The glass electrode is represented as AgCl 0.1 molar HCl glass. So it has a glass bulb which is important. This is what you will immerse in the test solution. Okay. This glass bulb should be fully immersed. The glass bulb should be fully immersed in the test solution. Then only you will get a proper value. So this is glass membrane bulb, okay, which is used to sense the H plus ion by by giving Na plus ions and H plus ions are interchanged by through the membrane. H plus ion and Na plus ions are interchanged. This is internal reference electrode is AgCl electrode. So yesterday we have seen the different types of electrode. One of the type is AgCl electrode. We have also seen calomel electrode. So inside this we have 0.1 molar HCl solution, and there is a platinum wire, okay, which is used for connectivity. Okay, platinum wire for electrical connectivity is used for electrical connectivity. Okay, the same thing now we are showing only the glass electrode here. Here we have inside the test solution. Okay, so as I told, this is the important part, glass bulb. Okay, which you should protect without getting damaged or broken for the glass electrode to function properly as a ion selective electrode. So here the internal reference electrode, this is glass membrane, and this is AgCl electrode, and this is solution of analyte. In this beaker we have solution of analyte which you are going to test solution. This is a porous plug here for drainage of electrolytes of electrode. This is 0.1 molar HCl saturated with AgCl is there inside. Okay, so this is Ag wire, AgCl electrode, Ag wire coated with AgCl. Okay, so here we have these two electrodes, internal reference electrode and this standard electrode. Both these things we have to connect it to a potentiometer, or we can say pH meter. pH meter is nothing but potentiometer can also be used for the purpose of if you use glass electrode and calomel electrode, potentiometer itself can be used as a pH meter also, or otherwise you can have a separate pH meter also. This is connected to a pH meter. Okay. Construction. The glass electrode consists of a long glass tube with a thin walled bulb at one end. Okay. The glass bulb, special glass electrode contains special glass containing 22% Na2O, 6% CaO and 72% silica of low melting point and high electrical conductance, which is used specifically for this purpose. Any glass cannot be used for making glass electrode. You need such a type of special glass for proper sensing. Okay. So this glass electrode made up of this specific membrane can be used to sense hydrogen ions. The bulb inside contains 0.1 molar HCl and AgCl electrode as an internal reference electrode. So what is the electrode reaction? As I told, H plus ion and Na plus ions are interchanged through a membrane. So H plus glass electrode which contains Na plus gives Na plus H plus J. The glass electrode, indicator electrode, will take the H plus ion. Okay. So thereby it senses the amount of H plus, which will lead to the determination of pH through glass electrode. Okay. Next, what are the advantages of glass electrode? Glass electrode is very easy to construct and simple to operate. The potential developed remains constant for a long time. The electrode can be used with a very small amount of test solution. The electrode can be used with a very small amount of the test solution, and this electrode can be used in the presence of oxidized impurities, reduced impurities, poisonous molecules, etc. It won't affect the sensing of H plus ion by glass electrode. The wide range of pH can be measured using this pH electrode. Okay, so application, we have already seen this. Again, I am telling there are different applications for this glass electrode, which is ion selective electrode for the determination of H plus ion. So glass electrode is one of the main application, and is also used in other analysis, like in environmental chemistry, like ion selective electrodes have applications in environmental chemistry. For example, used in the determination of concentration of several ions, Na plus, K plus, cadmium, mercury, okay, aluminium, calcium, etc. In industrial effluents, pharmaceutical polluted. In industrial effluents, pharmaceutical, and in polluted water, etc. There are heavy ions also possible. Lead, Hg, these are all called cadmium, lead, Hg, these are all called very poisonous, and they are called normally heavy metals. They should be below certain ppm in the water. So they use ion sensitive electrode to know how much ppm of this heavy metals are there in the pollutant water or industrial effluents, etc. It is also used in the determination of concentration of anions like chloride, nitrate, cyanide, sulfide, etc. Also is used in the concentration of gases, okay, using gas sensing electrodes. Okay. So determination of pH of the solution using glass electrode we have just shown here. This is the solution of unknown pH. Unknown pH, this is the solution. It's also called test solution whose pH has to be determined. So this is a glass electrode representation. We have a glass bulb fully immersed into the test solution. And this is a calomel electrode, which is a standard electrode. Your glass electrode has internal reference electrode of AgCl electrode. This is the external standard electrode. Both this electrodes are connected to a potentiometer or voltmeter, where it will give the value of your pH. Okay. So the gas electrode consists of a glass tube having a thin walled bulb which contains 0.1 molar HCl, and then we have a platinum wire is dipped. Exactly, a platinum wire is dipped in the glass electrode for electrical conductivity, electrical contact. The bulb is dipped into the test solution whose pH is to be determined. That's why we have said solution of unknown pH. The resulting glass electrode is combined with a calomel electrode. This is a calomel electrode. This is a glass electrode. Internally through a salt bridge. It has to be connected with a salt bridge, and externally through a potentiometer or voltmeter. Okay. So the EMF of the cell is determined experimentally, and at the same time the direction of flow of current is noted. That tells whether we have already seen in calomel electrode the direction of flow of current let you know whether the calomel electrode acts as a cathode or anode. Here in this case we will get the pH. Okay. So this is the representation of what we have seen in the previous slide. One side calomel electrode, another side you have glass electrode which contains H plus in the glass membrane, and which is actually the glass bulb is immersed in the unknown pH test solution. So the glass Na plus in the glass membrane and H plus in the unknown solution will get exchanged through a membrane. So this is the again for calomel electrode representation. This is glass electrode representation. EMF of the cell is given by EMF is equal to E glass, that is a glass potential of glass electrode minus potential of calomel electrode. So E cell is measured through a potentiometer, or you can say in this case pH meter. For pH meter, E cell normally is measured by a potentiometer. So potentiometer E cell is equal to E glass minus E calomel. So we will just substitute this expression which we used for E glass minus calomel electrode. So we get the expression like this: pH is equal to Eg naught minus E calomel minus E cell divided by 0.0591. So this is how pH is determined from the glass electrode. Okay. Next, so we move to the batteries. Batteries are a very, very important application of electrochemistry. Okay, so we will see what is primary, what is secondary batteries, more examples of primary batteries, and then what is the difference between basically these two type of batteries. So like that we will see. Okay, so introduction to batteries. First, a battery's voltage output and current rating are determined by, normally you have different batteries available. Even in primary we have different batteries available. So normally a battery's voltage output and current rating are determined by elements used for the electrodes, size of the electrodes, type of electrolyte used. Okay, these three basically determines the voltage output and current rating. So cells and batteries are available in wide variety of types and also shapes. Normally in cylindrical, in plate form, different forms are available and different types are available. See, for example, this is all we have regularly seen this type of batteries which are used in normal our remotes and in many places normal uses. Okay, so this type of batteries, this is a button cell type and this is a cylindrical type. Okay, so we have seen normally A type, AA type, AAA type. Okay, so for torches we will use little bit bigger batteries. For remotes and other things we use little bit smaller type batteries. So we have seen in our day-to-day life one-time use we buy every day, or any other Panasonic, any other primary battery, we will use it as long as we use it 4-5 months and then we will throw that. Those are all comes under the category of primary batteries, which can be used one time. It is a single time used as long as they have capacity to deliver the current, deliver the charge. We can use it. Once it is done, we have to throw it. So we know that we are changing batteries regularly for our day-to-day purposes. So we know about this primary batteries in different shapes and types. Okay, batteries. What are batteries? See, batteries are nothing but electrochemical cells. Okay, if there is one anode, cathode, and immersed in electrolyte, like for example, we have seen galvanic cell or electrochemical cell, it's called electrochemical cell. Whereas this different electrochemical cells, 2 or more electrochemical cells, are electrically interconnected, each of which containing 2 electrodes and an electrolyte. We call them as batteries. Okay, a battery is a combination of 2 or more electrochemical cells which are electrically interconnected to each containing 2 electrodes and an electrolyte in common. Okay, and in electrolyte. So the different electrochemical cells are interconnected through a series. Okay. So batteries are classified basically into 2 categories depending on the recharging capabilities. So as I told already, primary batteries cannot be recharged. It's use and throw. Once the power is vanished, we have to throw it. We cannot recharge it. Whereas the secondary batteries, where we use for cell phones and in several camcorders, cameras, we can recharge it. Once we use the battery, we can put it in the charger and recharge it. And again you can use it for 3-4 hours and again we can recharge it. So while using, we call it as discharge. The battery is getting discharged. Once it is fully discharged, we can again recharge it for 2-3 hours and then again we can use it by discharging it 3-4 hours. Okay. So primary batteries normally comes under the category of non-rechargeable and are meant for single use. Non-rechargeable and are meant for single use, to be discarded after use. So these are non-reversed, means the reaction is only one side, that is product giving power. That is, the reactant gives products, is nothing but it is forward direction reaction and it is giving power. Whereas in in reversible batteries or secondary batteries, the forward reaction, we call it as discharging. That is means we are using discharging, and after the battery is fully used, discharged, we again recharging. That is charging. Okay. So example we will see. So there are primary batteries are non-reversed, non-rechargeable, and are meant for single use. Okay. So example, Leclanche cell, dry cell, etc. Okay. Okay. Now secondary batteries, as I told, they are rechargeable and are meant for multi-cycle use. What is meant by cycle life or cycle use? Cycle means one charging, one discharging, and again charging. Okay. So that is called one cycle. So like this, we can use several times. We can use it and again recharge it, or we can use it again, charge it, like that. Several cycles it can be used. That is called life cycle of a battery. How many times it can be recycled, can be recharged and charged? That tells the life cycle of a battery. Okay. Secondary batteries. So secondary batteries are rechargeable and are meant for multi-cycle use. After every use, the electrochemical reaction could be reversed by external application of fades or lost or leakage due to or internal short circuit. Okay. Okay. Example for this: lead acid cell, nickel cadmium batteries or nickel cadmium cell. Even though we say cell, it means battery only. Okay. Combination of two or more cells becomes a battery. And we have lithium ion cell. We have lithium ion cell or lithium ion battery, which is very, very important. And it has a wide use now. This is a widespread use. There is for everywhere. Whatever the electronic gadgets we are using, we cannot imagine without lithium ion cell. So this has a widespread application, which we see, which we regularly use for our cell phones or laptop batteries or any mini computer, like any mini modern electronic gadgets, which are small and handy to use, contains lithium ion cell, lithium ion batteries. Okay. Next. What is the difference between primary and secondary batteries? So we will summarize whatever we have seen so far. Primary cells are non-rechargeable and meant for a single use and to be discarded after the use, whereas secondary batteries are rechargeable and meant for several cycle of use. Okay. Cell reaction is not reversible, only forward reaction. Cell reaction can be reversed. Forward, we say discharging. Backward, reverse reaction, we say charging. So these are all like you can always use rechargeable, or we can say the reaction is reversed. Okay. It cannot be rechargeable primary batteries, can be rechargeable secondary batteries. Primaries are less expensive. For example, everyday batteries, AA type or AAA type, we can buy for 15, 20 rupees or 18 rupees. We can use it and throw away. Whereas secondary batteries are costly, expensive. Okay. It can be used as long as the materials are active in their composition. Primary batteries, we have Leclanche cells, lithium cells, lithium ion batteries. Lithium ion cells means this is secondary battery. Whereas lithium cells means lithium metal is used here. This is a primary battery. Okay. Lithium metal here. Lithium, not lithium metal. This is in the form of compound. For example, lithium cobalt oxide, we will see while studying in detail about lithium batteries, lithium ion batteries. Okay. So secondary cells, we have lead acid, nickel cadmium cells, and several examples are the nickel metal hydride batteries are there, and we have lithium ion batteries are there. So in this, we will study lithium ion batteries and lead acid batteries in detail in secondary batteries a little bit later. Okay. Okay, this is just a representation of dry cell, where the primary, it's a dry cell or Leclanche cell. These are all examples for primary batteries. Dry cell, Leclanche cell. Anode is zinc. Zinc we can see here. Okay, ammonium chloride and zinc chloride, zinc separator. This is actually this is carbon rod, graphite rod. This is cathode, and this is here zinc. There is a separator between this cathode and anode here. Okay, so this is anode is zinc, cathode is graphite rod, is nothing but carbon rod, which is here. Okay, and electrolyte is a paste of ammonium chloride and zinc chloride. It's like a paste, so it slowly become dry. So when all the power is used, it dry, and nothing will be there once it is totally used. Okay, and EMF it can generate, this primary battery is 1.5 volts EMF. It can give 1.5 volts, 5 volts power. So you can use, depending on the usage, you can use 1 or 2 or 3 batteries in, like we are using like 1, 2, like that, 1 AA battery, 2 AA batteries, like that. Okay, so this is just a representation of a cylindrical batteries. We have some batteries like this. How inside it will look, that is what it is shown here. Okay, so whether a battery may be recharged or not, it depends on the cell chemistry or the cells used to make up the battery, active materials in the cell. We call it a cell chemistry. So whether a battery may be recharged or not, it depends on the cells used to make up the battery. Okay, a primary cell, cannot be recharged because the internal chemical reaction cannot be restored. Once it is used, it loses its capacity to get restored. Okay, secondary cell is also called storage cell because it can be recharged. The chemical reaction can be reversed. Okay, chemical reaction is reversible. So secondary batteries are also called storage cells. Okay, dry cells, as we have seen in the previous picture, has a moist electrolyte. Okay, that cannot be spilled. It's like a liquid. If liquid means it will get spilled. So whereas a paste, it cannot easily get spilled. Dry cells have a moist electrolyte that cannot be spilled. It's safer. Sealed rechargeable cells. There are sealed rechargeable secondary batteries that contain a sealed electrolyte that cannot be refilled. Okay, the electrolyte is also sealed. You cannot refill. For example, we will see in lead acid batteries, which we are using it for our inverters at home on car batteries. So we will see that H2SO4 solution can be H2SO4 solution, and also this distilled water. It can be actually once the distilled water is evaporated, the concentration of H2SO4 varies. So we can add distilled water to maintain that concentration of acid. Okay, so that is not sealed. That portion we can add electrolyte. Whereas in some sealed rechargeable batteries, we cannot get refilled by that electrolyte later, like we are doing in lead acid batteries. Okay, common types of primary cells. There are several different types of primary cells in use today, like carbon zinc dry cells, alkaline cells, zinc chloride cells, mercury cells, silver oxide cells, like that. Of course, mercury and all is replaced by environmental friendly batteries, because mercury is not considered as environmental friendly. So this is, but there is one type of primary battery is available. That's why we are saying that. So carbon zinc dry cells, alkaline cells, zinc chloride cells, mercury cells, silver oxide cells. There are different types of primary cells which are in use. For example, carbon zinc dry cell, we have seen in the diagram some time back. This is the most popular dry cell, primary cell, which is often used for the type AA, AAA battery, AA battery. Okay, which we are commonly used in our day-to-day life. Okay. We have already seen the negative electrode in this dry cell is zinc, positive electrode is carbon, output electrode EMF is 1.5 volts, output voltage of single cell is 1.5. Performance of the cell is better with intermittent operation. That means you need not continuously operate, you can intermittently operate. It is performance of the cell is better. Okay. Alkaline cell. Alkaline cell is another popular type used for AA, C type, D type batteries. It has the same 1.5 volts output as carbon zinc dry cell, but they are long lasting. Alkaline cells are long lasting. It contains a zinc anode, manganese dioxide cathode in an alkaline electrode. KOH is an alkaline electrode. It works with high efficiency even with continuous use. Even like we have seen in dry cell previous case, zinc, carbon. Intermittent use is for better efficiency. Intermittent use we have told, but here in alkaline cells you can continuously use. It works with high efficiency even with continuous use due to low internal resistance. Okay, that's why alkaline cells are in this. If you want continuous usage, it is better. Okay. The zinc chloride cells. This is called heavy duty type battery. All this comes under primary batteries. We are discussing primary only. So we have seen before alkaline cells, that is also a primary battery. Before that zinc carbon, that is also a primary battery. This is a modified zinc carbon cell. It's called zinc chloride cells and it's heavy duty. Okay, it has a little chance of liquid leakage because the cell consumes water along with the chemically active material. The cell is usually dried at the end of application. Mercury cells. Mercury cells contain zinc anode, mercury compound cathode and potassium or sodium hydroxide electrolyte. It becomes obsolete, means useless due to hazards. Mercury cells are avoided. It became useless, obsolete due to hazards associated with the proper disposal of mercury. If you cannot properly dispose the mercury, it is dangerous to environment and so it is hazardous. That's why it is not used very much, mercury cells. Silver oxide cells. This cell consists of zinc anode, silver oxide cathode and potassium or sodium hydroxide electrolyte. Again, it typically similar to a zinc carbon battery and alkaline cells. It gives 1.5 volts voltage. Miniature, it is available in miniature button form. Okay, like very small miniature sized button forms. It's available. Applications include hearing aids, cameras, and watches. So for watches, you might have seen we have a round shaped batteries, miniature batteries, where we will use. So this type of small miniature button sized cells are available for silver oxide cells. It's very highly very useful one and a good voltage, and it is used for niche applications like hearing aids, where the instrument itself is very small and you need a further small battery inside that. So for a specific purpose, this is highly useful. Okay, and it is, you can see in cameras, watches also you see it is a small place, it's a small area, and in that your battery has to be occupied. So it is a very good usage of silver oxide cells is there. Okay, lithium cells. As I told, lithium ion means secondary cells. Lithium cells means it's a primary cell. The cell offers high output voltage compared to the previous zinc, carbon, alkaline, silver oxide, everything. It has a long shelf life, low weight and small volume. Okay. It comes in two forms of 3 volt output in widespread use. Like for example, lithium sulfur dioxide, lithium thionyl chloride. Thionyl chloride is SOCl2. Lithium with lithium metal with thionyl chloride. Here lithium with sulfur dioxide. Okay. So again, lithium sulfur dioxide type batteries contain methyl cyanide liquid solvent, which is if it contains if the container is punctured or cracked, it can release toxic vapors. Methyl cyanide. Okay, methyl cyanide is again a very the vapors of methyl cyanide is not good for the environment, and it is very dangerous. So safe disposal of these cells is critical. Okay, lithium cells, you have to properly, after the use, it's a primary cell. So once you have used, you have to dispose it, or you should have a safety disposal of these cells. Then you can utilize these cells. Okay. So with this, I will finish the primary batteries, and we will continue the secondary batteries in the next session. The important secondary batteries which we are going to see is lead acid batteries. Its chemistry, lead acid batteries or lead acid cells, and very, very important, lithium ion cells or lithium ion batteries. Both these things are secondary batteries where you can recharge, charge it, use it, and again charge it for cycle use. Okay. And the reactions, the chemistry involved in this type of secondary batteries are reversible reactions, and we will see all those, what is the voltage and how it is constructed, details in the next sessions. Okay. So with this, primary batteries are over, and the introduction to batteries with primary batteries are over.
Like, share and subscribe. Hit the bell icon for more updates.